Okay, so let's say we're asked to evaluate the integral from 1 to e of ln x over x dx. All right, so I've broken down the steps for you here. The first step is to freak out hard. This step usually happens almost immediately, so you don't have to worry about that. Step 2, pick a suitable substitution. Okay, so what you're looking for when you're using u-substitution, or the reason why you even know this problem is a substitution problem, is because you can see a something, which in this case is the ln x, and its derivative, which is 1 over x dx. Whenever you can see something in its derivative, you can probably try substitution first. It's probably going to work. So the suitable substitution in this case, our first attempt anyway, is going to be let u equal ln x. Okay, now we're going to change over everything. Step 3. If u is equal to ln x, okay, so you can just look at the integral and say, I have to change over everything. The 1 and the e are in terms of x. This is the integral as x goes from 1 to e. We need to change those because it's now u. This x has to go, ln x has to go, dx has to go. Everything's got to go. All right. So first of all, how do we get rid of a dx? Because we only have u is equal to ln x. Well, we generated dx by deriving this statement here. So if we take the derivative of this, we get that du is equal to, what's the derivative of ln x? It's 1 over x dx. Okay. Oops, we accidentally generated this dx term. So now if we can sub out for dx. In fact, we can sub out for 1 over x. See, there's an invisible 1. It's ln x times 1 over x dx. All of that gets replaced by a du. Very convenient, okay? So this is going to end up being u times du here. Awesome. Okay, now we need to worry about the points of integration here. So when x is equal to 1, what's u going to be? Well, we said u is equal to ln x. So when x is equal to 1, u is equal to ln 1, which is 0. So u starts at 0. So if x starts at 1, u starts at 0. When x is equal to e, we get u is equal to ln e, which is 1. So u is going to go from 0 to 1. Okay, the next step is to look at our new shiny toy. This is the old integral, and if we change over absolutely everything, we get this as our new integral. This one looks really hard to integrate. This one looks really easy to integrate. That's why u-substitution is very powerful. And now all we have to do is evaluate your easier baby integral. So we start with this, we get to this integral, we know how to take the antiderivative of u, and so we generate this, and we evaluate from 1 to 0, which gives us 1/2.